So in today's video, we're going to be looking at a problem specifically asking us to look at a ratio table that's already filled out and decide, is it filled out correctly? What this is going to be looking at with the kids, having them do, is testing their knowledge of what exactly is a ratio. So let's go ahead and read the problem. It says, Ernesto runs 1 lap for every 3 laps that Kevin runs. The ratio table below shows this relationship. So we have Ernesto over here and Kevin right here. And it asks the question, is the ratio table correct? And if it, whether you say yes or no, you do need to give an explanation. So what I mean by it's testing their ability of, do they actually know what a ratio is? I mean, a ratio is a comparison of 2 numbers. More specifically, what we've been looking at is a comparison of 2 different things. So we may see a lot of times with Ernesto here, they're like, oh, well, you add 3 every time. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. And then they're like, oh, well, Kevin over here, 3 plus 3 is 6. Plus 3 is 9. Plus 3 is 12. However, that's an incorrect statement to make. All right, because the ratio is 1 lap to 3 laps. All right, so if we look at this, the next ratio would be 4 to 6, 7 to 9, 10 to 12. And we're asked, are all these ratios in the same exact ratio as 1 to 3? So we can do this many different ways. You can compare them. We could see if I multiply, if I get the same thing. But one of the things, especially with students that struggle a little bit, I make them come over here and write our 2 people's names. All right, so we have Ernesto, and we have Kevin right there. Okay. So what this is saying is, if they are running every lap Ernesto runs, Kevin runs 3 of them. So let's say that Ernesto over here, he runs a lap. That means Kevin is going to run 3 laps. All right, and that is represented right here, 1 lap to 3 laps. Now, if Ernesto runs another lap, Kevin's going to run 3 more. 1, 2, 3. And now we should have Ernesto ran 2 laps to Kevin's 6. We look over here. We don't have 2 to 6. We have 4 to 6. Now, right there, we know that's wrong. We said it should have been a 2. So we know now what our answer is. Is the ratio table correct? No. But now we need a good explanation why. All right, and we can't just say that no because the numbers are wrong. All right, why are the numbers wrong? What did they do differently that they should have maybe done? Okay, I give the students a lot of free range here. Sometimes they like to just I say you can explain by fixing the table and saying this is what it should be. If they want to use words, we should have a no because. And their explanation, one of their explanations, it could be, we should, and a lot of students, when we did this in class, they picked this up. You're not adding 3 going down. You should be multiplying by 3 each time. So Ernesto times 3 is Kevin's. 2 times 3 should give me 6. So if we're keeping Kevin's the same, the 7 should not be a 7. It should be a 3. 3 times 3 is 9, and that 10 should be a 4. So to finish off, no, because we should be multiplying. We should be multiplying Ernesto's laps by 3 to get Kevin's. And right there, that's a good question that I ask my students to see, do they truly understand what a ratio is and what they're doing when they fill out a ratio table.